Corporate finance practice problem using Excel. Net present value NPV versus internal rate of return IRR problem 2. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information, left-hand side, populating that information into the blue area on the right-hand side. We're looking at the net present value and the internal rate of return. These two items typically being applied to a situation where we have an initial investment. We're putting down money up front in order to get a return in the future. That might be the purchase of equipment. That might be some kind of investment, some type of project. The scenario being money up front. We're getting then repaid at some point in the future, typically years in the future. And the further out the repayment happens, or the projected payments are in the future, the more we want to take into consideration the time value of money. The two key calculations for the time value of money being the net present value and the internal rate of return. They are related. You want to know how they're related, and working problems this way helps you do that. So we have the initial investment. We're putting down $120,000, and we're projecting that we're going to get for that money in the future for years 1 through 5, $39,000, $25,000, $38,000, $50,000, and finally $75,000. Years 1 through 5, we have a discount rate, which we might also call, it could be called the required rate of return. It could be called the hurdle rate of the 9% here. Note that that rate does not simply mean that that's like the interest rate. It doesn't mean that when we do the present value calculation, that if we come out to a low number in the present value calculation, that we're really not making money typically, because that rate includes the opportunity cost of where we could put our money elsewhere. So that's the rate that we need to clear. So if we come out to a net present value calculation of 0, we have cleared the 9%, which includes the required rate of return, typically, if that's how we're using it, our hurdle rate that we want. So the bigger the number, the better, but anything over 0 clears the minimum threshold that we're saying is a qualifying project, given the fact that when we came up with the 9%, we included in it the required rate of return, which could include the opportunity cost of other places where we could spend our money. Also note that you might be using this calculation to decide on one project or multiple projects. We might have the hurdle rate and say any project over that hurdle rate is one we would invest in. We have the money. If it's there, if we think it's worthwhile, we'll put money in it. Or we might be saying we have multiple projects over the hurdle rate, and then we can only invest in one or a few of them, and we might then want to do some comparisons as to which one we should invest in. The number that gets this calculation to 0, present value to 0, is the internal rate of return calculation. So that's what the cash flow, meaning what would this cash flow be, or what rate would take this cash flow to 0. That's the internal rate of return. So let's first calculate the present value calculation. So we have to reassign our data in this format. This is how I would recommend doing it, just doing it year by year. Year 0, year 1. Start with year 0, that being the initial investment. I'm going to then copy this down or autofill it down. Going down to the 5 years, I'm going to center that, go into the alignment group and center. We're going to bring in our investment now. First, we had the investment. Any outflows negative, inflows positive. So we're going to say negative 120,000. Year 0 is what's going to happen. And then years 1 through 5, we're going to get a return on that investment. We're assuming, we're projecting the 39,000. Note that I am pulling this information from a data set. If you were to do this in practice, this is a projection. It would be nice if you use formulas so that you can then change your data set over here and change your entire projection. That's just good Excel, etiquette here. So I'm not gonna copy and paste it per se. You could, but I'm gonna do this format, imagining I'm using this Excel worksheet as a projection tool so that I'm pulling my data from the information, from the data information. So this is gonna be the total then. Total. And then let's sum it up using the trusty SUM function. The trusty sum it up. That means that we're going to have 107,000 of income after the 5 years if we're not taking into consideration time value of money. But 5 years out, we want to make sure that we are taking into consideration the time value of money. Let's go to the font and say, okay, underline. So let's go to the font and say, okay. So now we want to present value it at the 9%. And that would, if it is anything over 0, that means we get the 9%, right? We're covering the 9%. So I'm going to present value the first one here, which will be boring because it's going to come to the same number because it's at period 0. But it's nice because it will be uniform, and I could then copy that down using the autofill, which we will do later in the problem. So I'm going to say negative, present value, shift 9, rate. We're picking the 9% up over here, comma, number of periods, 1. Note that I'm picking the period up on the left-hand side. I'm not hard coding it. In other words, typing it. You could type it, but then when you copy it down, it won't flow down the way we want it to. So I would recommend setting up your table in this format just as a good practice in Excel. And then we're going to say comma, comma, because it's not an annuity, but present value of 1. Pick up that 120,000, and we get the same number. That's boring. Let's do the second one. It'll be different. Negative, present value, shift 9. Rate is going to be the 9% down here, comma. Number of periods is now 1, which I'm picking up on this side. This is 1 year out, comma, comma, because it's not an annuity, but present value of 1. Then we're picking up the 39,000 and enter. So now we have the 35,780. Note, once again, that does not mean that the current value is just like, it's like we just included interest, you know, the time value of money in terms of interest rate, right? We included our rate of return down here in it at the 9%. So let's do it again for the 25,000. Negative present value, shift 9. We have the rate is going to be the 9% again, comma. The number of periods is now 2, comma, and the payment is 0, comma, because it's not an annuity. Future value 25,000, pulling that back at the discount rate or the hurdle rate or the required rate of return, 9%, 21,042. Let's do it one more time. Negative present value, shift 9, rate 9%, comma, number of periods, 3 of them, comma, comma, because it's not an annuity. Future value then 38,000, and enter. That one's at the 29,343. Let's now do this the easy way, copying and pasting it down. So I'm going to delete these 3 just so we can show that we could do this nice and easy with the autofill, deleting these. I'm going to double click on the 120. I want to look at something outside the table. Anything that's coming from our data set is probably something we have to use an absolute reference on if we're going to be copying it down. And that's going to be in B11. So putting my cursor in B11, F4 on the keyboard, $sign before the B and 11, making it absolute. You only need a mixed reference, but absolute works, and it's easier, I think. Then I'm going to put my cursor on the autofill and drag it down. Double check that it does what we want by double clicking somewhere. It did not move that cell. That's what we want. Everything else looks appropriate, so looks good. Underline the last one, font group and underline. Let's sum it up. Sum it up. And there we have it. So that means we have the 50,331. So you might be saying that's pretty good profit, and your mind might then say, hey, so we're going to earn 50,331 after taking into consideration time value of money, which you might start be thinking as just lowering the purchasing power like interest or inflation. That's not what we're calculating here. We're saying this number, we present valued it not just including inflation, but the opportunity cost of the money, the hurdle rate of the return. So this 9% includes not just inflation in our scenario here, if it is the hurdle rate or required rate of return, but also the amount of return we expect to get, right? The opportunity cost of other investments. So the larger this number, the better, but anything over 0 would include the required rate of return. So the fact that it is fairly large after the 0 means like, wow, that looks like it's pretty good, right? Because it's clearing the 9% by a good distance there in terms of dollars. That's good. So now the question would be, well, what is our required rate of return in terms of percents? To get that, we'd have to look at the internal rate of return, which we'll do next time. Before we do, let's go ahead and do the net present value this way with the formula. I do not find this formula as useful because it seems to me you still have to set your data up in this format. You could just pull it from the data set, but typically you still have to set it up here. And I think if you do the present value running balance, pretty easy to do, and it gives you a lot more data over here by breaking out the present value on a year-by-year basis. So I prefer to do that, but you do have, of course, the net present value formula here, which is that NPV, shift 9. We're picking up the rate, 9%, comma, the values, a little tricky on the values. we have to pick up everything other than period 0. So all these numbers, not including period 0, then close up the brackets, shift 9, and then add to it or subtract from it the period 0 activity. In this case, I'm going to add the negative number, meaning if you picked up the number over here, you'd subtract it because this is a negative number, so I'm going to add the negative number. And that gives us a 50,331 again. So now the question is, well, all right, what number in terms of our rate of return are we actually getting? What's the actual rate of return of this cash flow? Meaning, what number would make the net present value 0 in terms of the rate? That's the internal rate of return. That's our next question. We can answer that by using goal seek to change this rate, but I'm going to go ahead and copy the data over here, just mirroring the data. I'm going to include the rate down here, which I'm going to put at the 9%, 0.09. I'm going to hard code it at 9%, and then, meaning type it in there, and then ask Excel to change this rate to whatever it needs to be to make the net present value calculation 0. That will be the internal rate of return. I think that's the most intuitive way to see it, but we will also calculate it using the formula for the internal rate of return, which I think is good, useful formula, but you want to know what it is. And then we'll recalculate and double check with the net present value formula. So I'm just going to mirror the data that we have over here. Same kind of thing, a little bit faster. 0, 1, 2. Selecting those 3 cells. Autofill handle, grabbing it, dragging it down to 5. Then align, center, and then the total's going to be underneath that. Total. And then negative 120, period 0. And then I'm going to pick up our cash flows from the data set at the 39,000. This time I'm going to do this with the keyboard. Control C, down arrow, shift, holding shift, down arrow, control V. And there it is, underlining down below. Let's underline that. Do our present value calculation up top. Negative PV, shift 9, rate. Now I'm taking the 9%, but from this cell down here, that's the cell that we're going to change. It's outside of the normal table up top. Therefore, if I want to copy it down, we need to absolute value it. I'm going to select F4 on the keyboard to do it, $ before the I and 10, comma, number of periods, that 0, comma, and the future value 120. When I copy this down, that 0 will change to 1. This format, or that cell will move down. This cell will not, because we made it an absolute reference. That cell is absolutely. So then we're going to go take that fill handle and drag it down to there, and there we have it. We've mirrored our data, underline. We've dragged it down. Let's sum it up now. Drag it down, sum it up. So now we've dragged down and sum up. Okay, so we've mirrored our data. Now we could change this cell and say, well, how high would this be? Because this looks like we're getting a good return, way over 9%. What if it was like 12%? Wow, it's over 12%. What if it was like 14%? Wow, because it's still above 0. So this is the actual return we're getting. Let's let GoalSeek do that for us. We'll ask Excel, could you make that cell whatever it needs to be to make that thing 0 so that we can get our IRR, internal rate of return, So we're going to go then to data up top, the forecast, the what if analysis, GoalSeek. And we're going to say we want to set that cell right there. We want to set it to be 0 by changing this cell. So make that cell whatever it needs to be to change that cell to 0. And note, if this cell was a formula or something, like if you said equals that 9%, it won't know how to do it. You have to have a hard-coded number or a typed-in number there. So I'm going to say OK, and there it does it. So it's 22%. Holy moly. That's a good. So now the question is, do we want to take on this project or not? Typically at this point in time, if it was the net present value, anything over 0 over here, we would say, yeah, we want to take it on because that 9% includes our required rate of return. And then we're going, wow, that's a pretty big, number over 0. What's the rate of return in terms of the percentage rate here? That's going to be our internal rate of return, and it's 22%. So do we want to take that on? It's like, yeah, it looks like it's a lot bigger than, what our hurdle rate is. So I don't know what the catch is, but it looks pretty good to us, at least with regards to this cash flow thing, if that's really actually the cash flow, because that's better than we can do elsewhere apparently, because we only have the 9%. So looks pretty good. Let's then recalculate this with the NPV and at that 22%, and this formula should come out to 0 because this rate, the internal rate of return, is the rate at which the net present value of the flows would be 0. So we're going to say, let's do that. It's going to say this is going to be equal to the net present value shift 9. Rate is now 22%, comma. I'm going to select all the values except period 0 here. That's our range. Close up the brackets, and then we have to say plus the negative number, period 0 number, up top, and that's going to give us 0, which we expected it to be because the internal rate of return is what we used as the percent, which is the rate that makes that cash flow 0. So now let's go the present value of the cash flow 0. Let's calculate the internal rate of return again, which should give us this 22%. Let's do that. That'll be good times, and I like good times, so let's do it. So that's going to be the IRR shift 9, and I'm just going to select this range of data. You got to set it up in this range, negative numbers, negative, and then positive, right? That's on the flows. And then we're just going to say enter, and there we have it, 22% matching the 22% here as well. So that's going to be the general rule. Remember, we might have multiple projects that we're comparing or simply one project, and we might have money enough for multiple projects, and we might say any project that's over the 9% means we might pick it up, meaning any number where the net present value is 0 that we calculate the flow, or any project where the internal rate of return is over 9%. Once we determine all the projects that are over the 9% possibly with this calculation, we might then limit the projects at some point. And we might want to say, well, what is the internal rate of return as a percent? And that might help us to compare multiple different projects if we want to choose between them as well. So note that these two calculations are related, and they are the two calculations that take into consideration the present time value of money, therefore being typically the preferred calculations to use for these long-term projects.